Welcome back to the stream, anyone who's tuning in early. This one might be a little bit different paced than the ones I've been doing lately. A lot of the stuff I've been streaming has been kind of exploratory work that ends up being just like really heavily edited down into these like 30-minute long videos. And I'm working on some of that still, but as kind of a break from the editing and some of the coding and just the general frustration, I thought I would just try to film some footage that would be very, very minimal editing and just kind of a fun little teardown and experimentation video that could lead to something else later maybe, but I would expect it to be something that would be just kind of a really quick editing job, and I can get it out there in between the longer videos. Tuco is already in position. So, yeah, as I mentioned this, but the main purpose of this will be to get footage for a relatively short video. So I think a lot of this is going to be kind of fussing with stuff on the DSLR, but we will actually have a video signal to take a look at on the computer, so that'll be in there too. Anyway, let's get this thing started. So, wow, clearly my throat is full of something. So I got this a while ago as kind of an eBay impulse buy. This is a Ntsc and PAL signal generator. So if you've ever seen color bars or some of the other alignment patterns that TV stations especially used to use to test their equipment, this is a little handheld doodad that makes stuff like that. And so I picked this up cheap on eBay, and I thought it would be an interesting device to play with and tear down, and maybe even if we get really ambitious, we could try programming it, depending on what kind of microcontroller there might be in there. So, yeah, what's interesting about this? So, as you can see, it's got a keypad, a small LCD, and up here, there's a video output. Oh, is this ever going to focus? I think I might actually have to move the camera a little further up. Man, I envy people like Big Clive who can often just shoot stuff on a single take. I feel like I always just have to edit stuff, but I'm going to try to make this video light on the editing. So will that actually focus close? So here you can see the I/O. We've got 2 channels of audio, weirdly on these XLR jacks. Definitely more like what you'd find at presumably a TV station instead of on the back of a television. And then video out, this is actually composite analog video, of course, over a BNC jack. Tektronix, one of their many video products. Not so useful anymore, which is why you'll find them cheap on eBay. And I already loaded this thing up with batteries. As you can see, it, what is this, 8 AA batteries. So I'll probably have to take those out to take this apart, but for now I thought it would be interesting to actually turn it on before taking it apart. So if you power this on, it greets you, says that it's from 1994, traveling forward in time many years. And it starts out wanting to give us some SMPTE, which are the standard color bars. So, and then if you press these, it gives you different test pattern options. So I figured this wouldn't be too interesting without something actually connected to the output. So have I not been recording any of this? Well, I guess that's less footage to edit. All right, I'm going to have to redo this introduction. So this was a random eBay impulse buy that I got a little while ago, and I thought it would make an interesting thing to just investigate as kind of a quick project in between editing these longer videos that I've been doing. So, as you can see, this claims to be a Tektronix PAL/NTSC signal generator, model TSG95. And in its heyday, it might have been used at perhaps a television station to calibrate equipment. Over here you can see the outputs, and they definitely look like something you might see on professional equipment from long ago, not something you might find on any modern consumer gear, or even consumer gear from when I was a kid. So you have composite video coming out over a BNC jack, then you have stereo audio coming out over XLRs. So quite odd. And then on the back, you can see the little Tektronix badge. And if you open this door, you can see I've already populated this with some modern batteries. It takes 8 AA's. So we'll see what's inside shortly and why it might need so much voltage. So on the front, there's this relatively inoffensive keypad. There's a train outside, which I think I might edit out. Maybe I'll take a swig. Gotta remember to move the camera or something when I do a really significant edit. You can see an alternate power input on the side, 9 to 15 volts DC. Really minimal, what looks like, I think, a 16:2 line, kind of classic Hitachi style text LCD up there, and then this pretty inoffensive rubber button keypad, pretty okay feel. So if you power this on, it tells us it's from 1994 and that it's traveled many years into the future to greet us. And immediately it goes into whatever mode you had it last in. So in this case it was generating some color bars. But as you can see, there are a lot of different patterns. I'm just pressing different buttons down here. So it also has a tone generator. Oops. So the only obvious audio feature here is this tone generator. I wonder if that's all we have audio-wise. And then this alphanumeric keypad seems to exist mostly for customizing these text overlays. So let's get this hooked up and see what the output looks like. Oh, did Microhex notice something about this? Oh, geez, that's a center negative jack. That sure is a sign of a bygone era that I am happy to leave in the past. So it looks like the station ID programmed in here was hello there. That was what it was set to when I got this from eBay. I'm not quite sure how to exit that mode. Okay, let's plug this into the analog output. Realizing I don't have the DSLR on the analog screen. I might need to... I might need a tiny DSLR somewhere, but that doesn't obscure this because I don't have another capture for this analog. Let's add another device. Because I want to be able to see the camera feed, and I'll have it recording, obviously, but I don't want to cover up this big blue area at all for the moment. So maybe the chat's going to get a little servo AF at the top. Ooh, that filtering looks terrible. Can we fix that? That little red dot is kind of in the way, but that's fine. I'll just leave that there. We can enjoy the weirdest little camera overlay. Okay, so now we have, oh no, the little microphone thing is just barely overlapping. I know that's overlapping the topic slightly, but I don't really care. Okay, so I have a little USB analog video capture dongle plugged in to my streaming rig, which I guess isn't necessarily something that needs to go in the video, but is useful for maybe people at home to know. I don't think I would use a shot of that, and it's annoying to get because it's just a messy wire running over into my rack. So let's just there we go. Some classic Ntsc color bars. It looks like we can use the arrow keys to move through the different screens. Maybe I can get that on the... So I think many of these are tests designed to look for specific problems that would exist in analog televisions, or just analog signal transmission in general. So like some of these look, like this looks like, oh, it's increasing frequencies so that you would detect problems that show up at specific frequencies. I don't know what this one was for, kind of a weird, like brightly colored band. Maybe it's looking for some type of color bleed. Some really interesting stuff. Ntsc 7 might be some standard. But I thought it would also be fun to take a look at these on an analog television to see if we can see some of the artifacts that maybe these tests would be designed to try to highlight. We edit the station ID. I suppose this has emoji. Oh, that was a space, but blank is a different character. I don't know how I finish. Oh, there we go. This reminds me of my dad's VCR. Not VCR. This reminds me of my dad's like camcorder that had like a VCR on a shoulder pack, but there was like a little keyboard on the side of the camcorder you could use to type stuff like this. I wonder if we're going to see a similar chip to what you'd see in an old camcorder. Is there anything else obvious that we can do with it? So we can turn the ID on and off. We just did this thing where we edited the ID. What does a 2-line ID look like? What if we put something way over here? That looks terrible. I was kind of expecting it to center it, but I guess there's a separate thing for ID position. Yeah. I guess you can just put it wherever you want. That's handy. Well, kind of. That's the minimum horizontal position. This is probably going to have a pretty interesting old school text generation chip in it. Oh, is it putting that in the vertical blanking? I think live should be between pink and red. Okay, what else can I do with this? I can store. Yeah. Storing. It's probably got some really slow EEPROM in it. Can I recall? Is there anything saved in here? Handheld. TSG95. Neat. Those probably are some factory stuff or stuff that the previous owner set. There's tone on and off, but we don't have any audio connected just yet. I'll connect that on the analog TV. I don't see anything else. All these are just characters. And we have this lockout key, which just locks out everything else. So if you press something else, then it gives you an error message. So that's probably what you would do if you just wanted to have this thing hang out in an equipment rack, generating something like this all day. That one's kind of nice too. Okay, let's try this on an analog television, because this being just a digitizer, it's going to get a fairly clean representation of the signal without having to deal with driving a CRT. I would expect to see this show up pretty cleanly on a fairly modern digital television too. But yeah, maybe if I had a really old television, it would show artifacts on some of these. Let's get this on the television. Cat time. Where is that? How did I slip and then hit the thing that loosens the camera? I think I want this to actually be more on the level of the television. Which probably means unclamping this. I suspect we are going to see some more interesting colors on the CRT, and we'll probably... I'm curious if I can capture any of the kind of flickering artifacts on the camera, because I'm sure we're going to see some of those too. Knee cam. That's getting edited out. I just need to give myself a little more wiring slack. And clamps. Yeah, I got the limit thing. I know you suck at files. the beer to be in the frame. What's the degree of freedom? Yeah, like that screenshot from chat. That's what these things generate. Oh man, maybe I should put the camera on a regular tripod for this shot. It's like the annoyance of fussing with stuff to move it versus fussing with this. So I'm planning on lining this up so I can get like a mostly full frame shot, but then I can also zoom out to reveal the thing that I'm poking buttons on. Oh yeah, that's gonna need some work. What are you cutting off? Yeah, so what is the longest I can hold this open? 30? And do we need that to be ISO 800? I think this might work better on 400 or 200. I'm not going to get rid of that sync. I mean, unless I am not shooting video. That's fine. See, I had to set this up with an RF modulator because this TV does not have reasonable inputs. So yeah, there's a lot of moire. These are solid colors. Can we get that on the screen too? It's a shame this LCD doesn't have a backlight. That one's complicated. Wow, so this is giving some interesting color fringing on the high frequency vertical bands. I don't know how much that's coming across on the preview. Oh, this one's interesting. So this one I think was all grayscale. Ntsc Multiburst is the title on this one. I think this one was all grayscale before on the computer. But here, in fact, if you look at each of, I don't know how much this is coming across on the camera, but in person it's really vivid where each of those vertical stripes is tinted either blue or yellow. Oh, that one was animating. This one's title is Bounce. Yeah, you can see this on a CRT. Look at the text. It actually moves as the background switches between black and white. And that is actually due to bounce in the power supply on the deflection circuit, I believe. Oh, are we not recording? When did we stop recording? So this test is actually named Ntsc Bounce, and it at first looks like it's just switching between a black background and a white background, but on a CRT you can actually see, I think, what this is designed to be measuring. It looks like the text moves in and out just a little bit as the background changes color, and I think that's measuring a voltage bounce in one of the power supplies, I think for the deflection circuit. That's interesting. I think I forgot to start it when I moved the camera, and I need to run through the sequence because I wanted to get that footage at least. I'll probably overlay it over something else and not use this audio. Press that a couple of times. This one is very subtle on the CRT. This is the Sine x over x pattern, which if you recognize that equation is sort of a sine wave that rapidly changes frequency. Sorry, that's not the right thing. It's a sine wave that gets kind of it's sort of a regular size sine wave near the origin, but then it decays very quickly. So I think you can't even see these on this CRT. On the digitizer earlier, we were seeing a pattern. Yeah, we were actually seeing the sine x over x pattern. I don't see anything here. Yeah, Robert says the sync function like Broadcom's logo. Yeah, is that actually focused? Anything here I missed? I'm anxious to move on and take this apart because I know I'm not going to use very much of this footage. Just want to make sure I've got everything. Tests like this are a little bit archaic these days, since now, you just have a rectangular grid of pixels, but when you actually had to line up the image on the front of a CRT, it was really useful to have something like this. You might be able to see some subtle colors on these vertical bands, yellows and blues. Those seem even much more apparent in real life. I don't know how well it's coming across in the camera, but I think that's part of the image that we were just seeing fully in grayscale on the digitizer, but here we're seeing the higher bandwidth monochrome content starting to interfere with the color due to, I assume this TV doesn't separate color as well as the digital, well, I assume this TV just doesn't separate the color signal quite as well as the digitizer we were just using. This one looks about the same. This one has the yellow and blue tint. This one has a little bit of the yellow and blue tint also, but otherwise looks pretty much the same as the digitizer. This one definitely looks, so this one looks pretty much the same in real life and on the camera, except maybe the colors are a little more vivid in real life. There's some yellow tinted bars, and then some on the right that are blue with those two red stripes going vertically. Let's look up the audio. It's not going to be interesting, but I want at least a little bit of a clip of it. I didn't bother hooking up stereo since I'm not quite sure what the point of stereo is, but I hooked up at least one channel of XLR to the TV's audio. So that's the tone generator. You can turn it on and off. Let's zoom in on the screen. So you can turn the tone on and off. Oops. What did I do? There's a tone menu where you can set the frequency. And I think you can enter arbitrary frequencies here. I'm just not quite sure what the UI is. So it's probably just an arbitrary sine wave generator. I think you can set the amplitude. Yeah, enough of that. So yeah, it makes tones, bars, and text. Let's see what kind of hardware they use to accomplish that. That's kind of a neat shot. So it seems like this thing knows how to make tones, bars, and text. Let's open this thing up next and see what kind of hardware they use to accomplish that. That's not going to be a usable focus pull. Why do I even try? All right. Okay, I think I need to move this camera again, and then we can get this on the desk. I'm going to have grease from this camera arm on my hand for every take. Oh, that's a good question from Tech Constantin in chat. What bandwidth does the output have? Is it 12 megahertz? Yeah, we can take a look at it on the scope. I haven't done that yet. I would expect it to push a little beyond what NTSC usually does just to test how equipment deals with that. How is this wire in the way still? There we go. Does it have a way to just blank out this whole thing? I need to use the restroom, but I'll be right back. Actually, maybe before taking it apart, we should take a quick look at it on the O-scope. I can just insert that in a little bit earlier. Oh, interesting. I'm going to maybe say this after the scope finishes being loud. Yeah, I need to make a slightly better message here. I've got a lot of characters to deal with, apparently 16 by 2. Should this edit in real time? Guess not. Anyway, this is also pretty good. You know, I mean, I can put text on top of this pretty easily using more modern technology. Oh, Vince is wondering whether the scope has a TV mode. It can sync on TV. I don't think it can display the picture as far as I know. But yeah, that was my next stop, is let's hook this up to the O-scope. Just need to get my camera slightly more organized. Let's take a look at the output of this on the oscilloscope. Where did I put that? There's the O-scope. Let's take that cursor out of the way. Oh, and I'm going to go ahead and reload the scanlime signal so that just in case it does have any way of displaying this, I don't want it to just say, BRB, don't go. Cool. A. I've got to remember the scope is on the green A button. That's totally something I'll remember, right? So, do I have a 75 ohm terminator? I'm probably just going to set this to 50 ohm and figure it'll be close enough, especially for such low bandwidth. Oh, that's juicy. So, I'm going to take out this mouse because I don't think I really want that on the screen. What do we got? Oh, look at that nice stable trigger. Is it triggering on every field? No, just field 1. Okay. Cool. Here's what the line structure looks like. So this has 0 volts at the black level and sync a little bit negative, which is a little bit different than I remembered composite video working. But I assume this is fine. So this is the color burst here at the beginning. Why are we not syncing with that? Can trigger on a particular line. Maybe the color burst phase is different per line? Wouldn't really expect that. That's interesting. The color burst oscillator seems to not necessarily always have the same phase. I wonder if that's done intentionally as a test. Anyway, let's just look at the overall pattern. So I'm just triggering on a particular line pretty early on in the video, like right after vertical blanking or so. Oh, lockout. Different grayscale brightness levels. You can see different modulated colors. We can actually take a look at a couple of the simpler patterns to get an idea. Like, this is a pretty good demonstration of how NTSC encoding works. What do we have? Greyscale bars. Yeah, so this is a 5-step grayscale pattern, and it's just going to increase DC levels without any modulation on top of that. These are the solid color fields. So NTSC encodes the color information using multiple phases of this 3.5 something or other megahertz signal. And it's important, the phase of the actual line data relative to the color burst matters, but the phase of the actual signal can change line to line, so I think that's what we're seeing here. So that looks kind of randomish, but I think if you were to compare the two relative to each other, you'd see as I go between, can I go between red and other colors? Or do they only have red? I guess the only color field was red. I was hoping there would be another color we could look at. Let's try to find the plain old color bars. So yeah, it's hard to see what's going on here since the phase changes a lot globally, and we're not looking at the relative phase here. But, I mean, you can see that something is changing every time the color bar changes color, but it's kind of hard to see what's actually going on at this level. I'm curious if we see anything interesting from those Sine X patterns. This is the Sine X over X. That's right what it says on the tin. That looks nice. It's a pretty good looking waveform. This is a sweep. Where's this top out at? It's only 4.1 megahertz. Was there another test that had really high frequencies that would be interesting to look at? Don't know how much of this footage I'm going to use either. Just maybe if I find something interesting. The classic color bar pattern on the oscilloscope. Oh, this is the Convergence Test, which is also for CRTs. It's the grid of black and white lines that we were seeing. Oh, and Tech Constantin in chat had a really nice real-time answer for my question about what the kind of bounce test was actually doing. And they're saying that the size change is mostly the anode voltage dropping. The deflection doesn't change. And the point is always moved constantly, only the intensity is varied. Interesting. Oh, what is that? FCC composite. Anyway, I think I'm mostly done with this. Oh, these were the kind of higher frequency test bars we were seeing that were interfering on the actual television. What is this one? .16 megahertz or so. Oh, one other thing I'm curious about is I am kind of curious what the text looks like on here. I'm trying to guess how the signal generation works, like what of this is analog and what of it is like direct digital synthesis maybe. Let's take something simple like the maybe the regular color bars, and let's go down to where the text overlay goes. Just going to guess where this is. Just turning this until I start seeing some chunks taken out of it, like that. So that's the black box that the text is surrounded by. It looks like the text might be generated by a different circuit, and they're just kind of switching between the text circuit and the test pattern generator. The text is coming out of somebody's shift register. All right, I think that's about all I care to look at on the scope right now, but... Oh, nice, Tech Constantin has a more complete explanation. The picture gets bigger with more intensity because of the lower anode voltage. The picture gets bigger with more intensity because the lower anode voltage causes the electrons to fly slower, therefore they'll get deflected more. That's neat. So it doesn't have to do with the deflection power supply, it has to do with the deflection's effect on the electrons. That's pretty neat. You can see that I'm like swapping between... I bet we're going to find a bunch of different analog circuits that generate these different patterns. I don't think it's going to be just a big old D to A converter, but I don't know, 1994, it could be either way, I guess. But I do suspect we're going to see a multiplexer that switches between kind of potentially even an off-the-shelf character generator kind of chip and then their test pattern generator circuits. Anyway, let's open this thing up, enough guessing. Oh, such cat. All right, let's turn this thing off, take the batteries out, and take it apart. It's feeling a little bit warm already. I can't tell quite where that's coming from. Take out the 8 AA batteries that were powering it through these tests, if I can manage to get them out. I think maybe AA batteries have gotten bigger since 1994. Looks like there is space for a proprietary rechargeable pack as well as 8 AA's. Just picking up any extra exterior shots I might want. I did say that I was going to try to make this a quick edit, but I do like to fuss with these things. All right. These aside. So, I think it was probably a good idea to take out the batteries in any case, but I don't think that was the way in. I'm going to put this aside, but I don't think we actually need to take that off. What is that? There's something weird happening here. There's a spider web in this screw hole. Okay, I guess this was like in somebody's garage for a while. Close enough. Gross. Okay, regular Phillips screws it looks like. Little self-tapping screws. One of them wanted to come with me, but I think this screwdriver's a little oversized. That's better. Do we have any other screws? Nope, this is coming. Ooh, there's some wires between the halves, I think. What do we have? Ooh, there's a bunch of wires. Huh. Yeah, thank you guys. So, it looks like we just have a few of these wiring harnesses to take off. But it'd be nice to know which ones go where, so I probably need to label them. Just trying to give myself a little slack too. I'll probably just cut this out anyway, so I shouldn't talk so much. Make it easier to edit. This is super interesting. I just don't want to rip off these cables without us having a chance to have a really good idea of okay, let's just go in here a little. So already this is super annoying to get into. We have the battery and everything else on the back shell of the instrument here, just attached with these plug-in connectors. And it's not like there's even just one of them, there's several of them. So I think I'm going to have to either just intuitively figure out how these should go back or be careful to label them. It looks like we have two here that are just for the XLRs. So they're probably the same. It looks like pin 1 is labeled, so that might be fine. Over here we have the composite output on the right. And then the one on the left actually goes down under so we can keep it connected. And then this one is kind of strange. Is it keyed? These all have the connector logo, like the housing is pointed the same way in all of these. Is that a keyed pin? I think that one's keyed. Let's find out. Let's find out without obstructing all the light. Oh yeah, I think that one's keyed. That will be easy to put back on correctly, I assume. And that's one of the audio, another of the audio, and then video output. Oh, video output, great. Okay, so what did we just take off? So these two are pretty clearly just the audio outputs. This one seems to be the power inputs. So it has 2 pins for the rechargeable pack and 2 pins for the AA string. And then this one is the composite video output. And then some big old grounding lugs there, I guess. Oh, that's part of the mounting for the XLR jacks. So if we wanted to power this externally, we'd probably go through this jack, maybe. We could also go in on the side if we don't mind the center center negative atrocity that it is. Okay, let's put that part aside. Oh, this is looking pretty nice. Wow. A lot of unusual stuff on here. So this looks like a calibrated oscillator, 27 megahertz. Set plus 7 hertz, it says. That's interesting. Several labeled trimmers here. Offset, Sine X. That looks like a fancy op amp. What is that? OPA 603. I'm gonna really quickly Google that. Can insert a page of the datasheet later. Oh, OPA 603 precision op amp. Burr Brown, now owned by TI. Yeah, so this is a precision current feedback op amp. Interesting. So this is probably just an analog circuit generating that Sine X chirp. A couple of adjustments. That's where the power comes in. That in there. So that's the audio outputs, those two. That's the video output. Some regulator. And there's several of these nice op amps, I think. Here's... what is that? The National Semiconductor... find any data for this. Oh, I searched for this and it pulled up something from the service manual for this part. So I just searched for the marking on that big national semi chip, and down here, service manual. Let's get a nicer view of this. Oh, nice. There's a table of contents. Oh, Chris says that big Nat semi-branded parts in the 90s tech gear are often custom ASICs. Interesting. Often mixed signal parts. So that could just be all the generation mojo going on in silicon. Anything interesting in here that we'll want to show off? Well, let's be going down here, not the table of contents. Wow, this lets you use a TV as a spectrum analyzer, I think. I think that's what they're doing. Like for looking at problems in the cable by sending out a sweep and then looking at the results on the television. Character amplitude. Oh, here's what we were just looking at on the O-scope. Nice. Oh, this is super useful. This tells us pretty much what's going on in this instrument and what we should expect when we take a look at it. So we have an ASIC and a microcontroller, EEPROM memory, segment memory. I wonder if you could program this to do games kind of like an Atari 2600. Since I assume this is like a really, really simple GPU, kind of like the Stella chip on an Atari. This is a lot nicer than what I was expecting. I was thinking back to a really simple, I was thinking back to a test generator that I saw in a magazine in the 90s sometime that was all made with analog circuitry. But it looks like this one actually does have an ASIC doing generation digitally and then sending it out to a DAC. So that's pretty nice. Also makes me really curious what you could do if you change the contents of this EEPROM. Port D. What do you think this is, an 8051? Yeah. I mean, plenty of microcontrollers have ports with letters, but... This is a lot of nice information. Does it tell us what the chips are? Oh, does this have a full schematic? There's a keyboard layout. Oh, that's all the designators for the parts on the board. Yeah. Wow, schematic. That's beautiful. 78C10. What even is that? Oh, NEC. Yeah. Okay, so that's the second biggest chip is this NEC microcontroller. I wonder what the toolchain support for this chip would be like. Interesting. So not an 8051, but something probably pretty similar. What is the other name this chip goes by? UPD78C. Some people looking for tools. Renaissance compilers. Neat, but there's a way to use their compiler as a disassembler. Interesting. So this is like a 16-bit version of, well, is this really a 16-bit version or an 8-bit version? 78KOR? Okay, this is something different. This is 78C. 78C11? When the first step is just figuring out like what the architecture is commonly referred to as. Oh, MAME. Interesting. I wonder what MAME devices use this. The Casio something or other? Oh, interesting. It looks like this is a relative of a chip that somebody decided to hack for fun in their drum machine. No, do we have tools for this? There's disassembler in MAME. That's pretty neat. Huh. Yeah, so it looks like MAME has a disassembler for this architecture, but there aren't really a lot of tools coming up. The service manual is pretty nice, though. So it says we have microprocessor, digital timing control, which I guess is their ASIC. ADG313, yep. Signal segment memory, segment address memory. Maybe we can probe some of this stuff on the O-scope and take a look at these memory banks as they're being used. This little EEPROM, the 24C16 down here, is going to have their firmware in it. That's pretty neat. It's the analog bits in their output stage. So they are generating all the test signals with a D to A converter right here. U14 MB4760. Yeah, let's take a look at that. Get this next to the microscope. I don't know, I don't think we even need the microscope for this. So before we look at this in too much detail, I do actually want to take this the rest of the way apart. So let's do that, and then I'll talk over it a bit. All right, how does the rest of this come out? J6 is. It's like I could find out the answers to all these questions by just reading the service manual now. So there's this wire going down under. Is it possible this has a backlight? I didn't see a backlight. What else would this be? Oh, there's nothing holding that in. This whole thing just comes right out. I think it needs to unplug from the keyboard before this can actually come off. Feels like I'm taking the keyboard with it, though. There's something in this corner. That plug is definitely a backlight. I didn't see how to activate the backlight. That must have been something else in software that you can do. Okay, yeah, this is just plugged down to the board below it in this way that's kind of hard to unplug. Alright. Couldn't tell whether it was possible to get this out with the keyboard board, but it seems like it wanted to unplug, so I was going to help it unplug. So the other side is utterly boring. We have the plug where pins go through the board to plug into here to attach the keyboard. I think the keyboard is going to be completely boring too. Doesn't seem to be attached, it's just in there a little bit. Like it's a little bit wider than the spot for it. That is mundane but beautiful. Nothing special. Some little buttons there. There really doesn't seem to be anything worth dealing with on this side, and in fact, since we have the schematics, we don't even need to see these traces for reverse engineering purposes. But it's nice to at least see it once, and then we can put it back. I want to take this off too, just for completeness. Nice little latch to hold the LCD down. Little piece of rubber. I think we should take the backlight out first. So this is pretty interesting. It has a ASIC, it has an 8-bit CPU, it has a DAC, pretty nice filtering on that DAC. You can make a pretty nice retro arcade console out of this, perhaps. It would just likely have Atari 2600 style graphics, if that. Since I don't think this is going to have like sprite logic like the Atari did. Come on. Pretty classic little two-line display here. Not a genuine Hitachi chip here, but somebody else implementing the same protocol. So yeah, the back of this board is pretty sparse. Mostly just a couple of signals, and then below that it looks like right below that we're seeing the ground layer, or maybe that's the top. How many layers are we dealing with? This looks like a 4-layer board. Alright, well, since the back is so boring, I'll just put this back on, and then we can maybe take a look at this as it's operating. Oh, I did actually want the LCD to be in there too. That whole thing should come out, it's just the keyboard PCB is a little wider than I think it's supposed to be. Yeah, that's the whole thing. Wow. This construction detail is kind of interesting. Can't recall actually seeing this done before. So the LCD attaches with these long pins that actually pass through this connector, but they enter on the solder side and actually pass just right next to the solder tails. So the pins actually go right through there, and they press through. That's pretty weird. Cute. Oh man, that keyboard PCB. Hard to tell if this is fully seated. I don't think it quite is, but that's fine. So between all the helpful silk screen labeling and the service manual, we can start to identify pretty much all the major components here, and even all the minor ones. So we've got this nice oscillator here, Y1, which is labeled 27.00 megahertz plus 7 hertz. This this ASIC here, model number ADG313 from National Semi, is their, what do they have it labeled as here? Let's start with the largest chip. So the largest thing here actually is not the microprocessor, this is actually an ASIC. So it's labeled ADG313. In the schematic in the service manual, it says digital timing on that section, and it's interfacing the microprocessor to a couple of different memories that are labeled the signal segment memory and the signal segment address memory. So from what that sounds like, it sounds like it's setting up kind of an indirect list where it's giving the ASIC some chunks of memory and then telling it how to arrange those into the signal that it wants. So that ASIC is probably doing the actual reading and writing arbitration on those memories, pulling the data out of it, and actually driving the D to A converter. So then this chip up here, let's get actually a good view of these. This is the digital timing ASIC, the ADG313. And so we can actually see it connecting right to this. What is that? I'm guessing that's a memory. It says U7. Oh, this one. So the digital timing section, yeah, U7 signal segment address memory. That has an 8-bit data bus. This has an 8-bit data bus. All right, so there's one of the memories. The other memory is U5. We're going to see a lot of traces going there. Is that this one? That says U24. That might be the memory used by the main processor. This memory is not labeled, but it looks like it's shared. Is that right? Yeah, this memory is shared between the microprocessor and the digital timing ASIC. That's interesting. This is a 27C512 memory. I don't know how big that is off the top of my head. So one memory shared between the CPU and the ASIC. This one is the signal segment address memory. And then the signal segment memory is U5. Is that going to be a different chip because it's faster or something? That should be... It is a different kind of chip. It's a 7C256. Ah, that's this one, segment memory. Yeah, so that's pretty interesting. So we have one memory that's accessible by both the microcontroller and the ASIC, then two memories that are connected just to the ASIC. This one's labeled signal segment memory, and this one's the signal segment address memory. Then the microcontroller itself doesn't have non-volatile memory, but there's a little 24C16 EEPROM, or maybe the microcontroller does have flash memory and that EEPROM is just for settings, because that seems small. What is 24C16? That's 2 kilobytes. That could be their code, but it might not be. That might just be settings. So this might be a settings EEPROM. Either way, that's 2 kilobytes connected to the microcontroller. What is this yellow chip? Is that U23? I think that's a resistor network. So these are fancy op amps. These OPA 603s. Yeah. And let's also point out maybe the D to A converter. Oh, I think the audio is, this is interesting. Is the audio digital and just coming straight from the ASIC also? I was just looking for the DAC just to confirm that and was looking at the audio path here. So output drivers for the audio, muting transistors, and then this looks like a plain old audio codec, like a digital in, analog out kind of thing. Let's see if that's correct. ML2036. Oh, no, it isn't. This is a programmable sine wave generator, so it doesn't have arbitrary audio output. It just has a really nice beeper. But internally it has a D to A converter. It just connects it directly to a lookup table. Okay. So this only knows how to make sine waves. That's a little less exciting. But you can make games with only sine wave beeps. It's better than only square wave beeps. How high does this go? DC to 50 kilohertz with a 12 megahertz input clock. Neat. Alright, so for audio, there's a special purpose chip that only knows how to generate sine waves using an internal lookup table and DAC. So that is U12. Can we find that? So these are the audio outputs with op amps, muting transistors, and then the actual sine wave generator is going to be U12. Oh, there it is. That's the audio chip. That is a sine wave generator, ML2036. So it only knows how to make sine waves with that. They use an external voltage reference and calibrate the tone level, it looks like. The person next door is using exercise equipment and shaking the entire desk. What is this? X9C? Oh, is this a counter? Oh, this is a digital potentiometer, probably. And then they have a old-fashioned potentiometer for trimming. Let's see if that's right. X9C 103S8. What is this part? Did I even get the name right? Because this looks mostly like spam so far. This looks like a digital potentiometer. And I'm just saying that because, well, so this says pot CS, like potentiometer CS. These are like digital up-down controls. And this is probably wiper high and low. So I'm assuming that's for setting the the volume, like the reference amplitude for the sine wave generator. That's the voltage reference, 2.5 volts. What about the video output? So test signal DAC is U14. Also MB 40760. Oh, there's the DAC. So this guy, U14 is the D to A converter for the test signals. Okay, that critter there, U14, the MB 40760, that is our main D to A converter for the test signal. And then it goes through several other analog layers here, which we can see goes through several other analog layers here, which we can see in a lot of detail in the service manual. So there's a trimmer for gain. Maybe also this FET is for gain. A lot of options for filtering this that they gave themselves. So it looks like, I don't know what kind of low-pass filter that this is, but it's some kind of LC low-pass filter for cleaning up the output of the D to A converter. And then they feed that into another one of their fancy op amps. And this is an offset voltage that also comes from, I think, the same reference down here that drives the amplifiers, or the audio amplifiers. So then we have an offset for the output amplifier that comes, again, from the same 2.5 volt reference that we saw down here in the audio circuit. And then there's the test signal out. Gain calibrations just with this passive network here. And so this has nothing to do with the sine x over x signal. This is just a calibration that's, I assume, relevant to that function somehow. So this is adjusting... This will affect the feedback path of the op amp. I just don't know what they're doing with that. It's some kind of compensation in the output amplifier. Oh, I guess that tells you what's in their proprietary battery pack. 9.6 volt NiCad. And this is their NiCad charger circuit. A little current limiter, I think. Well, alright, maybe we'll just poke around on this while it's on. It would be really tempting to try to get some of our own code running on this thing. But maybe the first step is just trying to look at what the IOs of the microprocessor are actually doing here. Program memory is stored in the ROM, U24. The ROM is accessed with the help of the ASIC, so the ASIC is doing the memory mapping here. And where did we see U24 already? It's like the computer knows that's on this page somewhere. U24 F3. Oh, U24, that big one. Oh, so that's the one that's connected both to the microprocessor and the ASIC. That's the ROM, not RAM. This thing. 27C512. Okay, so ROM. Well, that might mean that if we did want to hack on this, an early step that would help a lot and would let you actually write code for this would be to have an EEPROM emulator for this chip. So are U24 and U7 both ROMs? Sorry, maybe that isn't 7. Maybe that's... Well, it says U7. What is U7? I'm just wondering because it's like the same kind of chip on the board. Oh, segment address memory. So is this a ROM? Let's just look up these part numbers. Yeah, EEPROM. So why would the addresses be in a ROM? I guess because they can be, like they're only doing limited number of tests. Interesting. That's making this seem less appealing to reprogram all of a sudden. So I was actually slightly expecting to see a separate circuit for doing the text overlay, but all of that's just going to be a part of their ASIC. I'm curious whether the ASIC can use its text overlay capabilities to do bitmapped graphics. Like, for just hacking around on this thing, it would be pretty interesting to kind of interpose on this bus a little bit. What is the clock frequency of this thing like? That sure is noisy. I'm not seeing the clock. Oh, here's the clock. Oh, and the microcontroller clock is generated by the ASIC, of course. Why wouldn't they? Looks like that's half of the D to A converter clock. So, not going to be a huge speed demon. I'm sure we can easily get an FPGA to do whatever we want with this bus. Alright, how will we easily power this thing up? Maybe we'll just attach to the alkaline battery inputs. Where's the power connector? Oh, that would be on the other schematic. Yeah. Let's weigh 8. Let's just verify this. Yeah, that's a 12-volt supply. Do we know why they wanted 12 volts yet? I mean, it probably made some of the analog stuff easier. This stuff runs on plus and minus 5. How does it get that? That's interesting. Huh. So this is a chip designed as a regular buck regulator. But it looks like here they're using it to convert 12 volts to plus and minus 5. So we have an on-off circuit, power down. What is that? Protection. Battery charging. How interesting. This not installed diode CR7 kind of tells a story. It's like they thought they could have this automatically switch between the battery and the external power, but instead they have it doing it mechanically through the switch here. I've never seen a power supply topology like this to my memory. So I think this diode's going to be reverse biased. I don't know what it's protecting against, but this is... I think this is the output of the switching node here, and this is going to be... So like the left half of this transformer is like a pretty normal 5-volt buck converter, going from 12 volts down to 5 volts. So if you ignore the right half of this transformer and just assume this is a regular inductor, that looks pretty normal so far. But then if you look at the other side, I think they're using that same magnetic flux coupled to this other inductor, but in the opposite direction, to just generate a... I think this is going to end up being an unregulated, roughly minus 5-volt supply, since it's going to be regulated through the feedback on the plus 5 supply. But then if you're drawing about the same amount of current, then this will end up being about minus 5 volts. That's interesting. Let's just hook this up. Brown, no pin. Why is brown plus and yellow minus? That's so weird. Is that connector that I thought was keyed not actually keyed on the board? How did I miss that? Oh, Chris in chat says that it used to be pretty common back when the bipolar rails were more normal. Interesting. Yeah. just going by the service manual, but I'm going to double check that this is actually how the device in front of me is wired. I'm super confused by what they chose to do on the schematic here. So this is the no pin down there. So this is what we're seeing in the actual enclosure. We're seeing this wiring harness that has a missing pin. And then the battery's wired. Is it actually wired like this? Brown, no pin, orange, yellow, green. And then, yeah, yellow is minus, brown is plus. So that matches what we're seeing here. Oh, is this just weird because there are just a couple of things confusing me. This is a little bit strange because they broke this out as one thing for NiCads and one thing for alkalines, whereas what we're actually seeing in here is one connector for alkalines plus a battery pack that plugs in and has two connectors. Anyway, I'm not going to go into detail about that. Wow, this case feels like it has a lot of glass reinforcement in it right here. Or maybe it's just, I don't know a good test for that, but it feels really, I don't know, brittle, I guess, but probably in a strong sort of way. So the other thing that was confusing is that they have this BAT minus label here where that pin doesn't actually exist. So that makes me wonder if maybe they also designed this to just plug into a 2-pin connector, which would be kind of convenient. Are we actually seeing a connection on the board between pins 2 and 4? Yeah, I guess we could do that if we wanted, but I'm just going to plug this in where the battery was actually connected. All right. Such cat. Okay, well, let's get this camera again. Oh, I see. I see, so that cat in chat points out the plug is designed to be symmetric. The schematic was just designed to make that as confusing as possible. That makes a lot more sense now. All right, take this new power supply for a test flight. This was kindly sent in by Mark. Right, so we want 12 volts. Oh, I'm still not quite used to using this one. There's the on-off. How do I go to the current limit? Right here. this have a rating on the back for how much current it wants? I'm just going to start it at like a 1/4 amp. All right. I need to longen those a little bit. Oops. All right, starts out drawing no load because the soft power switch. And just try to keep the keyboard in its home. Okay, looks like under normal operation, it's a little under my 1/4 amp limit. That's lucky. Let's bump it up a little bit. All right, let's poke around a little bit. Let's go ahead and keep an oscope channel on the output of this thing, maybe. Oh, maybe I'll just use no scope probe instead of the coax there. Do I want pin 1 or pin 0? So this is unterminated, so the amplitude is going to be a little weird, but otherwise it's probably fine. And this will be interesting using the NTSC triggering to poke around in the memories. All right, what's interesting here. So U14, we should be able to see some correspondence between the DAC input and what we're actually seeing on the output. There's a nice ground here. It's the most significant bit of the DAC. Yeah, so there's all the bits coming right out of the ASIC. I'm curious about how the memories are accessed. So maybe let's take a look at what's the first RAM called? Well, let's get my curiosity about the ROM out of the way. I kind of want to probe the ROM first. Let's just look at the addressing on the ROM and see if it's at all synchronized with this. That'll tell us whether the CPU has to stop running during the video generation or anything like that. U24. It looks like it's not doing much, and the not much that it is doing is unsynchronized with the video. Can we verify the CPU clock here? Microprocessor clock. Wow, it has 2 clock phases. That's interesting. I don't have a good reference for where these pins are. So here's what I'm seeing in the service manual, the microprocessor clock input. How many pins are even on this chip? Looks like 17 on a side. Is that right? 68 pin? That sounds like a size I'm used to. So 33 and 34. Ah. That's where they are. Am I wrong about where pin 1 is on this package? The ASIC run's a little warm. Okay, 33 and 34. It should be these two, right? We find them on the other side, perhaps? I'm just kind of poking around for fun right now. Oh, is that the clock? Was I just off by 90 degrees? That doesn't look like a clock. Okay, this is what, 68 pins? What? That can't be right. Really? Who would design something like that? Really? Pin 1 is in the middle of one of the sides on this package. Can I find an actual reference for this? I think I want a PDF. Okay, let's see if this matches throughout the schematic. So if I'm looking for the clock, that would be on 33 and 34. Alright. In that case, I think, this ground is making me so nervous. It's going to be a nicer place to get ground. Let's just unplug this for now. Let's see how terrible my signal integrity is. I think this is what I'm looking for. No. Oh, that looks right. Let's try to find a better ground. Is there a ground on the keyboard connector I can pilfer? Yeah. I'm gonna have to point the thermal camera at this thing. That'll probably be interesting. Okay, ground. Is there a ground on this chip that I could use? Pin 35, which is right next to the clock, is ground, if I can reliably find that. I kind of want to get a good picture of the clock. Don't think I want it that badly, though. Well, I'm just going to stick this close to the power supply, which isn't really where I want it. Oh, nice. So the CPU clock is synchronized with the video. That's really nice. .5 megahertz CPU clock. Oh no, that's it's trying to measure the video frequency. Let's add that correctly. Oh, is it getting the same frequency for the CPU clock? Okay, that looks right. 13.51 megahertz or so. Oh, did I switch that off the scope while I was making the measurement? Sorry. I don't even know how I did that. There we go. There's the CPU clock. 13.51 megahertz. And delightfully, it's totally synchronized with the video, since they're all coming from the same oscillator. So let's maybe poke at something that's going between, like I'm curious about that RAM and the, well, and the ROM for that matter. Yeah, so what about the signal segment address memory? That's U7. This one right here, ROM. Signal segment address memory. And so this is a 27C020, which I think is an EEPROM. Let's look that up. .27C020, this says 2 megabit. Interesting. What could this be? So, most significant bit or least significant bit? Are these also going to be numbered weirdly? Because I think this is also a PLCC package. Is this 33 pins? I think that's 32 pins. Is that a real PLC package? PLCC. Yeah, 32 is a real thing. I hate this numbering scheme. For real? And so if I'm looking for one of the data signals here, so D0 is 13, D7 is 21. They seem to be contiguous there. That's like this side of the pin and some ears, or of the chip, and its ears. Oh. Just probing each bit of the data bus coming out of this EEPROM. So we get this interesting pattern on, what is this? This is pin 13. That was the least significant bit of this EEPROM. Least significant bit of the signal segment address memory. So it's possible, like maybe let's take a look at the address lines. Like maybe what we'll see is this like increments as it goes across the line and then like picks a different thing depending on where it is. Maybe it's set entirely in software, maybe it's a lot more complicated than that. I think this is going to be the least significant bit of the address. Maybe the segments it's talking about are things that are like a little bit larger than a pixel as far as NTSC is concerned. Text doesn't seem to affect the addressing going into here. Or did I speak too soon? This is looking counter-like. Wow. So that's changing. I'm just interested in how that state where it's not really changing much seems to be high for a while, and then it goes low. And that isn't a pattern that repeats within a single line. Maybe that's due to differences in what the last, like maybe that burst of activity is the ASIC reading a bunch of things from this EEPROM, and then it just happens to be left at whatever the last address was. But it's interesting that we'd be seeing different behavior depending on what the line is. Are we having triggering problems? Let's try triggering on all lines. Alright, let's try a different memory. It's getting a little bit of a picture of what's going on, but it's still kind of fuzzy. We could actually cheat and just read more of the Surface manual too. Oh! Just noticed some interesting labels on here. So there's some inputs on here that look like they're not being used, like maybe they were for debugging. So there's a background and character. I'm assuming these are inputs tied to ground. That might be something different, but maybe that's enabling parts of the internals. Maybe if there's just a complete problem with the character generator, but they wanted to use this chip for something else, they could tie this. And then C add, like character memory maybe? Yeah, where's the character ROM stored? Because that would be interesting to mess with. And then this is a RAM. Where's this a ROM? 7C256? This is a RAM, 32K. Yeah, let's poke around on that some. I think that's in a similarly annoying package. Oh no, that's a normal package. Yay. This is back to like SO dual row packages, not like weirdly numbered PLCC things. Zero and two. Okay. So around the bottom of the chip we have some data pins. That's one of the data pins on the RAM. I want to pick just another one of those lines with text on it because I think those might be more interesting. So this is one of the lines of our color bar plus text overlay. It's possible this RAM doesn't get used at all for the text. Yeah, we might not see the loading happening during the text. It looks like there's a bunch of stuff that gets loaded by the ASIC during the horizontal blanking. So I suspect, during the horizontal blank, the ASIC is going to have some laundry list of stuff that it needs to do with the memory, and that's going to be happening here, and then it'll probably store some stuff internally that it clocks out during the line. Well, I'm running a little low on stuff to just poke around in on here. Just to pop up a level of meta. My plan with this was mostly just to kind of edit this down into just a pretty quick little video, and I don't know if it's going to have much of an overall theme, or if it'll just be like, let's take this apart and see what's inside and play with it. I mean, it would be interesting to do something cool with this device involving reprogramming it, but it seems like this is early enough technology that we can't just like reflash it. It actually has like ROM chips, or at least non-erasable programmable ROMs in it. So to do much development, we would first of all need to deal with some pretty annoying tools probably for this proprietary, well, a lot of microcontrollers you could call proprietary, but I guess what specifically is annoying about this is that it doesn't seem to have like widely supported tools. It's like kind of an old and obscure architecture at least by my standards. And so we'd probably need to find some assembly and disassembly stuff for that. It looks like MAME at least has a disassembler. We can probably find an assembler somewhere, maybe even a compiler backend. Might have to write that if we cared. But to get that far in any kind of a convenient way, you'd probably want to emulate some of these ROMs with an FPGA. And if you're doing that, you might as well just have an FPGA talk to the ASIC. So then maybe one thing that could be interesting to do is to just try replacing this micro with like a PIC or an AVR or something, and then write code for that, and then use this to generate video. But I don't know. None of that seems like a super interesting use of time. A lot of them seem kind of interesting, but I think I might be better off just using this as is, as a kind of interesting title generator on my streams or something. But maybe there is some way we could hack it. I'll have to distill that into some kind of outro. Let me see if there's anything in chat that I need to catch up on. I often have the sound notification. I haven't actually set up the visual notification, but yeah, I try to keep an eye on the chat, but I don't always do a great job at it. Oh, there's so much good chat here. Oh man, I like that suggestion from Harmless Rubber Cats that instead of a ball grid array, invent a package with 100 concentric circles so the chip can be soldered in any orientation. You could just have little droplets, and they could be even, like, imagine you wouldn't need a pick and place machine. You could just kind of dump a bucket of parts on your board, and they could all have unique footprints, and then you just kind of like add some liquid and agitate the board. Like maybe this whole thing happens in like a vat of flux, and you just agitate the boards and slowly evaporate the flux, like simulated annealing. I think the problem with this is you'd have very low yield, but it would be fun. Oh, Joseph Hall in chat mentions, or asks what the drum machine was that I mentioned earlier. That's a good question. So just in poking around on this, I was just looking for resources on this processor. So I think this is the CPU we're dealing with. Yeah, let's get that on the camera too. Oh, I want to look at this on the thermal camera. That's right. Speaking of cameras. All right, so focus. So that's the ASIC. This is the 8-bit CPU. This is so old school. It has external memory bus and all that. So D78C10. So if we go back here, yeah, PD78C10. So this is the datasheet, NEC. Oh, here's the pinout that I wanted earlier. Man, that numbering. Oh wait, what? This isn't it. This is something different. This is mini flat. Where's the? Here it is. This is what we have. 68-pin PLCC. I think I had an So this is what we have. 68-pin PLCC. I think I actually had an old Xilinx FPGA in this package. It was socketed. I might have had some problems that turned out to be related to this. I mean, I didn't design the board for that. It was an old board from XS. It worked really nicely, though. I think I just was hooking something up to it and maybe blew out the SRAM at some point. Program memory. Wait, so does it have built-in program memory? On-chip ROM. Okay, we have the version without on-chip ROM. Cool. So the code is entirely in these EEPROM chips. And so the thing I was mentioning about a drum machine, I think I was just searching for tools related to this. Let's see if we can find this again. I think... Oops. Oh, yeah, this is it. Casio RZ1. So this is not the exact same processor. Oh, it's really close though. I think this is just the version with onboard ROM. But yeah, definitely the same architecture. Oh, interesting. So they've got on-chip ROM, but then they've also got an expansion ROM. So I guess you could put some code in the expansion ROM to dump the built-in ROM, maybe. So this has this person wrote a disassembler. Neat. Yeah, that's great. It would be interesting just to pull these chips out and read the code off of them, although I don't have a parallel EEPROM reader, and so that would mean like building or buying something and doing an annoying desoldering process. So it wouldn't be something I would do unless I had a plan for what to do next, probably. Let's take a look at this on the thermal camera to see how much it's warmed up while we've had it going here. It's drawing about 2 watts. I just gotta take the case off my phone. We can turn off the O-scope and have a little bit of quiet. Although the power supply also has its own fan. Not going to do landscape. There was another app I think that might do landscape. Do I not have it anymore? Maybe not. Oh, it'll record sideways, it just doesn't do the screen cap sideways. Well, actually, I don't know if it is recording sideways. Well, I might have to sideways it in post. So that big spot of heat is actually not even the entire ASIC, but it looks like just part of the ASIC. How much of this is parallax? Yeah, so that warm spot right there is the output op amp. That's the linear regulator chip. That's the ASIC, in particular the part of it right next to the RAM. Then the RAM itself is a little warm. And that is the D to A converter and another op amp. Microcontroller runs pretty cool. All right. Well, I hope you enjoyed that little teardown. It was a fun break for me from the video editing. And man, it's like I'm trying to do two things at once. I want to actually talk to people on the stream, but then I also need to record an outro for the video, which I could do later, but it's nice to get all the audio I need during the stream. Oh, do we have a date code on this board? Did I forget to look for that? Is that 94? A little quality control dot up there. Can't quite tell what that says. Maybe C4, maybe 94. I don't know. I thought the firmware said 1994. Oh yeah, let's get this hooked back up to the TV and record another little bit of that while I try to stammer my way towards an outro. It does mean I have to put this back together. I don't know if I'll include that footage in the video, but it should go back together pretty quick. I mean, I don't have to put it back together, but I kind of want to. Good idea, Kyle. I approve. Yeah, I'll have to figure out what to do with this. I have a feeling that, like, epic software hacking is not necessarily going to be worth the effort, but just using this as part of my video setup seems pretty interesting. Especially if I can involve a VHS somehow. Like, record this on a VHS tape loop. Maybe I could hack the microcontroller to take in messages over a serial port. Custom characters would be nice, though. Like, if I start going down that, then I'm going to want to adjust the font so that I can include all the international characters I want. It's hard to tell if... Oh, I forgot a plastic piece. That's why the keyboard is all mushy. I forgot part of it. This stabilizer. Oops. I do that right? No. Okay, so this board goes in next, and then the plastic thing. Character generator is in the ASIC according to the service manual, says Michael, so probably not very hackable. I wonder if the ROM is going to be in the ASIC too. I guess it probably would be, but you know, I think what I would want to do is maybe look at the RAM access pattern and see if it changes as I change the text. Oh, should I do that before putting this back together? I think you're really good at nerd sniping me in here. I'm going to keep putting this back together, but I think the next test that I probably would do is to take a closer look at that RAM access pattern during the horizontal blanking and see what's actually being loaded there. This is the cliff that I see myself near, because I can tell this would be a fun project to work on, but it would also involve soldering like 100 tiny wires to all these parallel buses to a large FPGA. And so it would be interesting, but it would be a lot of work, and the hardware required to hack this could easily generate several arbitrary NTSC signals that just do whatever I want, so. It would certainly be nice just to do a firmware modification. So maybe if I can get my hands on some like basic parallel EEPROM equipment, then I could do that. I'm sure that stuff is super cheap nowadays. The character generator really reminded me of some of the standalone stuff that I've seen. Like, you just get a chip and give it serial, and it splats it on the screen. So I was kind of hoping it was going to be one of those. Oh, keyboard feels much better now. (1994) version 1.0, is that what it said? Well, I guess you don't really rev it much when you're dealing with ROMs. Oh yeah, Kyle's saying that maybe suggesting maybe the IP that they used for the character generator could be similar to one of the independent chips. It's just third party. Oh yeah, and Michael's reminding me to check the backlight. So we found a backlight inside, and I just hadn't actually seen it in here. And yeah, it's possible it just isn't working. Maybe it's supposed to have a backlight all the time. I don't see a lot of menus going on here. KKAT, nice. There's not a lot of UI here. I mean, we could check the manual. Oh. Yeah, they advertise a backlit LCD, which is not what I've been seeing, so yeah, maybe it just isn't working. The service manual says there's a backlight power control. Oh, the lockout button turns on the backlight, maybe? Oh! Oh, there is a backlight. It's just super dim. You see it on? You see the backlight? Isn't that the great backlight? Off, on. Off, on. Yeah, it has a backlight. Well, that would be an easy mod. Like, I could replace this with any LCD in the same form factor that has a nicer backlight. Kyle is asking if it makes that horrible squelch. I think it's a low voltage backlight. It looked like an LED. Yeah, so I guess that's what goes on. The lockout, when the lockout is active, it turns off the backlight, but when the keypad is doing its normal thing, the backlight's on. So maybe somebody just left this on for a long time and the LCD gradually faded its backlight? I don't know. Weird. KKAT would be pretty cool if I get this TV next to Tuco. I hear Tuco stirring. be easier to put the tone back in post, I'm not quite sure, but get a little bit of that. So we have blanks and spaces. Oops. We also have an easy power switch. Yeah. So yeah, if you don't put in blank characters, then you just end up with a big box like this. But then you can adjust the shape, I guess. I can manually animate this like a screensaver. Oops. Hit the corner. I don't think it hits the corner, actually. So if I go left, that's as far left as it goes, and it disappears into VSync after it gets above there. It does go all the way down, it looks like. That was only 41 steps vertically. All right. What else can I do with this? Oh, we have a couple of special characters. There's some arrows. Punctuation. This thing does get a little warm as you use it. You can't actually point it to the middle that way. It's everywhere. I could just tinker with this. It would be fun. It would also mostly make me want to poke at the firmware. Well, should actually wrap this up. Peter's asking if it can do underscan/overscan. It didn't seem to have anything that let you move things around to measure overscan and underscan. It has this pattern, which you could use. Like, I think those are supposed to be demarcating the areas that you're supposed to be able to see under all conditions. So it's kind of like a worst case thing. I guess it doesn't recall a stored position or setting or any of that, just the text. I hope you enjoyed this little random hardware teardown. It definitely surprised me. I was expecting something with a little bit more old school analog circuitry in it, and so it was surprisingly modern in some ways, but still kind of an old enough digital circuit to be a little bit annoying to hack around on any further. But it's still a pretty interesting little piece of kit, and I hope I find some way to use it in my little television studio here. Handheld vaguely sounds like a gaming achievement, yeah. Oh, is there anything else I need to say? I don't know. I think I can add anything else I need in post. I have a mic. I can do voiceovers. Do we need to check in with Tuco? Tuco is still very well asleep right now. Alright, I think I'm going to stop fussing with this and do the rest of it in post. I will see you on the other side of this. So I guess my plan now is to just turn this into a really quick little edit and just put it out quickly, but then I'll keep working on my other edits and keep working on stuff for the Tuco bots. I've mostly just been kind of angsting about how to lay out code and stuff in there and haven't made much progress since the last time I talked about it, but if you haven't been with us for a little while on that project, the one where I'm working on a bot to follow around my cat, it's actually going pretty well. I've just been kind of procrastinating, making some design decisions for how to lay out the firmware, since it's one of those things that I think no matter what I do, it's going to be kind of a mess. So I'm just trying to figure out how much of a mess to brace myself for. But that's all coming soon. Anyway, thanks for tuning in, and A special thanks to all my patrons who keep the lights on in the shop and make all of this possible. Help my cat keep getting his food. Help me keep getting my hacks. So thanks again, and I will see you all later on the next videos, on the internet, on Twitter, and everywhere else hacks appear.